We're going to work two for loop exercises here at the end of this chapter. The first exercise we're going to look at is how to use a for loop to compute the factorial of a number. The factorial of a number, first of all, is notated like so, 5 exclamation point. And what that means, it means to take 5 times 4 times 3 times 2 times 1 and compute that product, and that is the factorial of 5. You don't have to do 0. 0 factorial is defined as 1. So we can leave that out because it looks kind of confusing to write it like so, because it looks like you're saying take all these numbers and multiply by 0, and that would leave you 0. But by definition, 0 factorial equals 1. So let's write a for loop to compute the factorial, and we'll just do 5 as our example. So first thing we need to do is create a couple of variables, number and factorial. We'll choose integer for these variables. Prompt the user to enter a number. Get the number in from the keyboard. Set the factorial variable, or initialize the factorial variable to 1. Since we're going to compute a product, we have to start with 1 so that we don't end up multiplying by 0 all the way through. Now we're ready for the for loop. What we do is we set the loop control variable I equal to number, the number that we want to compute the factorial for. Our relational expression says while I is greater than or equal to 1. In other words, we're going to be decrementing from number down to 1. And then, since we are decrementing, we will decrement I each time through the loop. The body of the loop is simply the statement we need to compute the factorial, which is factorial times equal I. So I didn't put it in braces because it's a single statement body, and most of the time for single statement bodies you don't need to bother with the braces to indicate a block. And that's all we have to do. Let's write out the answer. The number factorial equals, and that's it. Let's build and run the program. I know that 5 factorial should be 120, so we'll try that. 5 factorial equals 120. So as you see, we're going through the loop, starting out with I equal 5. So we take 5 times 1 for the first time through, and then factorial becomes 5. Then we take 5 times 4. Now factorial becomes 20. Now we take 20 times 3. That becomes 6. In fact, rather than just do that, we can watch the results of this going through the loop or writing out factorial each time. Add it to the body of our loop. We need braces to do that. Now let's build and run again. We'll work with 5. And so there we can see the result. The last computation, 120 times 1, makes that look kind of confusing, but that's what happened. When we take the current value of factorial 120 and multiply it by 1, that's our last step. Let's work with one larger number just to see how fast factorials can grow. Let's do 10. And so you see that the number grows rather rapidly as we increase the size of the number that we're going to compute the factorial for. If we're not careful, we'll run out of the range for integers, so I better stop there. But it'd certainly be worth your time to experiment and try some larger factorials and see what the largest number that'll fit into int can be used in a factorial computation. Now, our second exercise is going to involve a little bit different computation. This time what I want to do is I want to display a histogram of a set of numbers. And a histogram is just like a bar chart. And we'll have to use asterisks to represent the histogram. So for example, our histogram will look like this. 5 for 5 stars for the number 5. Let's count those. I just typed them in. There's 11, like so. And like that. Okay, this could be the basis of a very simple statistics program or just some way to display data in a histogram form. So let's write the program to do that. First thing we're going to do is comment out our factorial program, since we don't really need it, but I don't want to take it off the screen. So we're going to draw this histogram for 3 numbers. So we'll create our variables now. We'll call them data 1, data 2, and data 3. Prompt the user to enter the numbers. I'll just work through that really quickly. By now you're very familiar with how to perform these operations. And then the last number. Okay, now we're ready to write the loops. So we're going to need 3 loops. The loop will start with our loop control variable equal to 1. Our condition will be while the loop control variable is less than or equal to that particular data item. And then we're going to increment I by 1 each time through the loop. All we want to do is write out an asterisk from 1 through the value of the variable. At the end of that, we want to display the number and an indel to move to the next line. Now, rather than type this loop 3 times, what I'll do instead is I'll copy this and paste it in and just change the variable names. Again, just a little shortcut that always saves a little bit of time. So all we have to do is change data 1 to data 2 here and here. Perform the same thing. Change data 1 to data 3 here and here. And now we should be set to go. So let's build and run the program. Let's type 7, 11, and 5. Okay. Now you see we made just a slight mistake. And of course I knew that was coming up, but I thought I'd leave it in just to see the kinds of things that you make mistakes with when you're first starting out the program. We forgot to put a space between the last asterisk and the number. So we need to go back to each of our second cout statements and add a space between cout and the variable itself, the variable value. And one more time for data 3. Now let's build and run. And there we go. So you've seen 2 good examples of using for loops to get some practical work done. The next chapter, we take another step in our C++ journey and knowledge and learn how to write functions. Functions give us the capability of writing modular programs and being able to reuse programs that we've written for one program in another program.